Hi, everyone. My name is Mayukha Vadari. I am a software engineer at Ripple, and I'm going to be talking about XRPL plugins. So how many of you have ever had like a vague idea for an XRPL ledger amendment? Even like a vague idea? All right, cool. Now, how many of you actually have any idea on how you would implement that? Okay, that's what I expected. So this talk is going to be all about how you can build your own amendment. And we're going to do a little practice. We're going to do a little example as well. That's a bit of a surprise. So some background. Some of the things that I'm going to be expecting as a baseline knowledge are, you know what Ripple D is, not anything about the code, just what it is. You know the basics of some of the different transactors that already exist on the ledger. You know how to code in Python. If you don't, you can work out our example on pen and paper or pair up with someone who does know Python. And if you have your laptop out, you have Docker installed. This is a hands-on workshop. So if you have your laptop, please pull it out, and we'll use it after I get through my slides. Yeah. I have a tendency to go through slides fast, so please let me know. Feel free to raise your hand if you have any questions at any point in time. So this is an overview of what I'm going to be talking about, how the XRP ledger processes transactions, the parts of a plugin, a little bit of a demo and a code overview, and then it'll be your turn to write some code. So first off, what exactly is a transaction on the XRPL? Well, a transaction is the only way that you can modify the XRP ledger state. You can create, modify, and delete ledger objects, which is how the XRP ledger stores data on ledger. And you can commit data to the ledger that users and servers have access to through various different requests. And any transaction has to be submitted by an account. There are a few exceptions called pseudo transactions, but those are kind of out of the scope here, so we won't be discussing them. Now, what is a ledger object? A ledger object is how the XRP ledger stores on ledger data. And they must be owned by an account. There are also a few exceptions, like the amendments objects, but these also don't really matter for this talk. And here's an example of kind of the vague structure of a ledger entry type, of a ledger object. Make sense so far? So this is how the XRP ledger processes transactions. You have a submit request, which is how you submit a transaction to a Ripple D node. And then Ripple D proceeds to check the format of this transaction. Does this look like a transaction? Do I know anything about what this data is giving me? All of that sort of thing. And if it does look like a transaction, it gets the transaction type from that transaction, and it passes it on to the correct transaction handler for that transaction type. Now, what's in these transaction handlers? Well, these are the core transactor functions here: pre-flight, pre-claim, and do apply. Pre-flight is basically an initial check. What is basically literally everything you can check about the validity of a transaction without needing to know anything about the current ledger state. One example might be, is this transaction signed correctly? Does it have a valid signature? Not is the signature mapped to the account correctly, but which would require ledger access, but just is this a valid signature at all, or was there some sort of corruption that happened there? Pre-claim is what is everything that you can check about the validity of a transaction, but you only have read-only access to the ledger state. So this might be, for example, is your account's sequence number correct for this transaction? Something like that. And do apply is where you're actually applying this transaction. And if it fails, you can just throw another error. You can do some sanity checks to make sure that it won't fail, that sort of thing. Does that make sense? Now for the parts of a plugin. This is kind of what makes up an amendment, typically, when you're writing a new feature amendment. You have your transactors, which is basically the code that's running it, that's processing a transaction. You have your ledger objects. You have S fields, which are basically your serialized fields or parameters for your transactions. Serialized types, so some examples of S fields are something like amount or destination, all of the parameters that you see in your transactions. Those are all S fields. Serialized types are the different data types used by RippleD, such as a 32-bit integer or an account ID. It's pretty rare that you'll ever need to add a plugin serialized type, but it is possible if you have that need. Amendments here refers to just the amendment itself, not the associated code. You can think about it as just like the gate or the door that goes to all of this functionality, just that actual barrier, not the room behind it, which is all of that code, and that's in all these other parts of the plugin. Transaction result codes are the various result codes that you can get in response to a failed transaction, or a successful one for that matter, but usually you're only adding failed transaction codes because there's only one success code. So one example would be tech path dry if you've ever failed to send a cross-currency payment or something like that. You may have seen this error. Invariant checks are a special XRPL feature. They basically just double check that something that wasn't supposed to happen never happens. For example, creating new XRP or creating an XRP trust line, something like that. For some features, you might want to have the ability to add a new invariant check. Like for example, escrows, you don't want an escrow to have an amount of 0 because that doesn't really make any sense. Yeah, and inner object formats are essentially when you're defining a more complex object field, such as the signer entry field. There's some subfields to that, so you might want an inner object for that. And RPC requests are if you want to create a new request, like for example, account NFTs for XLS20. This feature hasn't been written yet, so that's still TBD. These are really the only 2 bits that you'll need to worry about for our example today. This is the brief overview of how exactly a plugin works. So you have RippleD, your running instance of RippleD, and you have XRPL plugin, which is a library that contains a lot of information and objects and models that RippleD uses. And that you can then convert to a native language. In this case, we'll be working with Python. And then you can use that as a basis for your plugins so that you can send information back and forth between RippleD and your plugin, like for example, to process a transaction, and the plugin knows how to understand all of this data. Any questions before I go into the demo? All right. So here's my little demo. That is small. Is this legible? Yes. Cool. So this is all the files that I've gotten here. All of these .xr plugin links are my plugin. Python, so in order to be able to use these things, there are these things called dynamic libraries. And those are basically ways where you can link in different packages at runtime instead of at compile time. And Python doesn't really have any ability to generate these, so I've got a little bit of a C++ wrapper that basically calls out to my Python file at runtime and pulls in all the relevant information so that it can talk to RippleD more effectively. So the example we'll be first looking at is dummy.tx. I am very creative with names. So we've got some imports here. And this is my pre-flight. Basically, what dummy.tx is doing is it's just basically a copy of set regular key, which allows you to set an alternate key pair for your account. So this is my pre-flight. It's pretty bare bones. All it does is pre-flight 1 checks some basic stuff, like I think if you have a sequence and that sort of thing, and it makes sure that that's valid. Then it checks your flags. This transaction doesn't have any flags, so if you have a flag, it'll error. And then it's checking if your regular key is equal to your account. There's no point in setting an additional key pair if that's the same as your master key pair. That doesn't really do anything, so we can just throw an error in that case. And then pre-flight 2 does things like check your signature and make sure it's a valid signature and all of that. And actually, before I go into do apply, let's look at this transactor object, which basically contains all of the overview of transactions. You have the name, dummy TX, the transaction type, which is basically a unique value that corresponds to every transaction that's in RippleD. Transaction format, you have two elements here. You have the regular key, which is optional, and the ticket sequence, which is also optional. And the consequences factory type doesn't really matter here, so I won't discuss it. And then you have your pre-flight and do apply function pointers that basically just point to these two functions. Now let's get into do apply. So first, we get the account. The square brackets is how you get information out of an object, basically. And actually, I'm going to move my little pointer here to make this a little easier to read. And then you kind of fetch the account info. So this basically just gets the raw account name, account ID. And this then you look into the account and you pull the account root info. And there's some, your first set regular key is free. And so that's what I mean by the weird fee stuff, which for simplicity of examples, I skipped in this. And then you check if there's a regular key set in your transaction, then you set it in your SLE, which stands for ST ledger entry and is basically any ledger object that you're modifying. And if it's not set, then what you want to do is you're trying to unset that regular key, so you can just delete it from your ledger entry object here. And then at the end, you can just return success. Questions? Was that confusing? Yes?
Does your other language code have some kind of access? What kind of context do you get access to?
You get access to basically all of the content stuff in theory. I haven't written all of the wrappers yet, so not all of the functionality necessarily exists right now. But in theory, once I implement them, they will be. Yeah, anything that a transactor has access to, you probably have access to in your plugin.
Okay, cool. Thank you.
Yeah.
Sorry, I missed the beginning. What is CTX?
CTX that is a good question. I forgot to explain that. CTX is a context that you get from, that RippleD passes into this function, basically. And it's basically like how you access information from the ledger. CTX.tx is the transaction that you're processing. CTX.view is how you get information from the ledger, like the state of a ledger object, for example. Like this is a ledger object that we're modifying here. Make sense? All right. Now a slightly more complicated example that I'm not going to go into too much depth about, but that you will probably need for your example. So here I have like a fake escrow create. I made up some other functions or some other parameters that I added here just for testing purposes. So there's some twos after some of these function names. But the important thing that I wanted to go over here is how you create a new object. So first you make a keylet, which is basically like like an ID for an object. You want to make sure that you want to create your ID for your object, and then you can create the actual ledger object based on that ID. And then you can fill in all of this information into your object. And then this insert function on the view is where you actually put the object on the ledger and make the changes. And down here, this update is how you're updating an already existing object. So you use insert, and that's kind of how you commit the changes to the ledger. So you might make all of your changes, but if you forget that last commit statement, none of it counts. It's just like committing to a database. Cool? This code will be accessible later as well. So next we have our little example. So I'd recommend that for the hands-on part of this workshop that you work in groups of 2 or 3, but feel free to work solo or in larger groups as you see fit. Yeah, and this is our example, NFT escrows. So for those who need a refresher, an escrow is where an asset is held without anyone being able to access it until some condition is met. In the XRPL world, that's usually a condition or a time requirement. So for those of you who have your laptops and have Docker installed, you can install my little Docker container that has all this setup done. Where's my little thing? So I actually put the link on a slide. I forgot about that. If you go to this link here, bit.ly/xrpl Apex plugins, it'll take you to this page right here, which has this Docker that you can pull, Vadari repo/xrpl-plugin-apex. If you have a Mac M1 or M2, or I don't know if there's an M3 yet, you'll need to add that platform on the end because otherwise it won't work. Which I have an M1, so trust me, it won't work. So there's some helpful docs here. If you, I'll put our little template up on the screen for those who don't have their laptops. If you want to work it out on pen and paper or your Notes app. So you should be able to access this page via the bit.ly link. It'll pull you into this Apex directory, which has all this data. You've got this basic run.sh that you can run to run your example, which this won't do anything. Sometimes there's some timing issues. So this is just the RippleD debug output. And if you scroll up here, you can see that the NF token escrow create sample transaction that I have in run.js here is just running here. And you can fill in all of your parameters here. So we'll go through the first couple steps together. I've got a little template already set for you with some numbers and things in order. This order is kind of chaotic, as you can see here, but trust me, it makes sense for being able to see changes. So let's start out as a group. What are different fields? Marco, would you mind passing around the microphone? What are different fields that you think need to be in this ledger object? You can look at the current existing XRPL escrow object for thoughts. Yes? Sorry? Destination. Yeah, destination. What else? You need more than the NFT ID. You need the whole NFT. So so you actually need this SFNF tokens object to store your NFT. In your escrow. Condition. So I'm not using condition in this particular example because working with conditions is complicated. But yes, in theory, you would want a condition. Anyone else? Hint, look at the other things that are in the current escrow. Expiration. Yeah, you need the SF. You need cancel after and finish after. Anyone else? That's pretty much the main stuff, I think. Forgot to pull up my solution on my phone before I came up here.
Is there any way to apply fees to this process?
Sorry?
Are there any way to apply fees fees to the groups?
Yes, so the default fee will be applied automatically. You don't need to worry about it in this. There's a separate function called calculate base fee that I'm not going into in this particular talk for time reasons, where you can adjust, where you know how some transactions have different fee amounts. You can adjust that in that transaction, sorry, in that method. Yeah, that's pretty much it in your ledger object. Now the transactor. You need a few more things in your transactor. So what are the elements that we need in our transaction? Sorry? Account. Yes. The account should already be in there, so you don't need that, actually. But you do need the account in the ledger object. So anything that's a default field, you don't need to put in. But, you know, okay, so we need to get our NFT. How do we get that? No, we just want we want to put an NFT in escrow. So how do we get our NFT? Yeah, exactly, the NF token ID. And we also need to fill in all these fields in the ledger object. So we probably want those fields as well. The NF token we can get from the NF token ID, so that's not needed. But we still need the destination and the cancel after and the finish after. But yeah, that's pretty much the basics of it. And the next step will be basically writing code. So those of you who have laptops and have this Docker container installed can mess around with that if you'd like. I've made it a little bit of a tutorial. And my little GitHub gist here has a bunch of helpful links. So would you rather, so not many of you guys have laptops, so we can do this in two ways. One of which is the 7 people who have laptops can work on this and everyone else can hover, which seems unpleasant for the 7 people who have laptops. Or we can work on it together and you guys can pull up some of these links on your phone. Is that reasonable? Cool. So let's go to number 3 here. Actually, first, let's see what happens if we run this. I need to update my run script to have some actual fields. And I'm already minting an NFT in here, so I can just put that in my little script. And honestly, I think this is going to fail because I didn't import anything yet. Yep. All right, time to import things. So if I go to the top, then I can import all the things that I'm just using. This is bad programming, but it's faster, so. Those of you who are doing this on your own laptop can be smarter about this, but yes. Apparently I can't do this. Oh, where did I put that forward? Great, fixed my imports. Now I can run my script, which basically all this little script is doing is just running rippled, running my little JavaScript thing that all it does is just mint an NFT and stick it in my escrow, and then it stops rippled. So this output may be a little chaotic, but all right. So if we scroll up to our output, you can see that we have our NF token escrow create. This is our little transaction here. It was validated with the TES success, and some stuff was minted. Yeah, nothing really happened. So, because we haven't done anything yet. So the first step here is we want to actually put our little escrow object into the ledger. So how do we insert this ledger object into the ledger? You can look at the documentation. You can look at the escrow example. There's some examples to look at there. Yep. Yep, ctx.view.insert. So now, I believe this will crash, but it will create an object. As expected, it crashed because of some SHA-map issue. But you can see that I do have a created node, and it is an NF token escrow. There's nothing in this object, but it was created. So the next step here is how do we add the escrow to the owner's directory into your account directory? Looking at the escrow create example might be helpful. I believe it's the line that's right after the insert line in the escrow create example, if that's helpful, or the couple of lines. Anyone figured it out? Yeah. ctx.view.dir insert, and you just pass in your account and the key, which is the keylet, the ID of your ledger object, which is the keylet, and you get the directory page as a result. You want to make sure that that's not, that actually returns something. Because if not, then the account has too many ledger objects and can't create anymore. Sorry? Oh, thank you. Now, if I run this, maybe it won't crash. I don't know. It still crashed. But we also created a directory node, so there's more data stored in this little account. And it now, the owner count number has changed, so the account object now knows that it owns one more account, that it owns one more object. So it owns the account root and this escrow object. So what's more, I want this talk to be useful to you, and I don't really know if it is right now. So would you rather continue to look for these answers yourself, or would you rather I just show you the solution and we go through it together and you ask questions? All right, seems like people want me to show the solution. So it is actually in this same Docker container, and because I am creative with my folder names, it's in a folder called answer, and it's called solution.py. So just to show you that this works before we go through the code, if I run the run.sh here, it's loading this plugin, which takes a couple seconds for it to fetch all the data, and all of its processing, and it stopped. So if I scroll back up at my, here's my NF token escrow create, and it was successful. And if we look at all this metadata, we do have this directory node still. We have a node that was created for the escrow. It's got all of these fields, your account, your destination, what time it finishes. I don't actually know what time that is off the top of my head. And the actual NFT that I minted in the previous step. And you can see that the NFT was removed from the page, or the page itself was removed because the NFT is no longer owned by this person. It's in the escrow. Yeah. Note this solution was written by me. Yes?
When the NFT is now in the escrow, does the escrow has an NFT page?
No, well, the escrow has this NF tokens list. I couldn't figure out if I could store a raw object, so I had to store it in an array. So theoretically, you can store multiple NFTs here and have it be a page. You could have your NF token escrow create take a list of NFTs potentially instead of just have one. But yeah, the account does not own the NFT. Effectively, yes, the escrow does have an NF token page.
But just internally?
Yeah, internally. That's just how the data storage works. So if we look at the actual code now, scroll past all of these imports that I actually did correctly in this example. Yeah, this is just for demo purposes. I wrote this in like 4 hours, so it's definitely not production ready. We have our little ledger object here and all the different data pieces. Some of the additional ones that we didn't include are the source tag, the destination tag, some nodes to make it easier to search for these objects with, for example, account objects, and the previous transaction ID and ledger sequence for tracking of this ledger object's history. We have our little amendment here that gates this feature, our keylet. So I actually filled in the pre-flight and the pre-claim, which I didn't do previously, but you can do as an exercise to the reader if you'd like. And I did some additional checking as well, but not all of them. So what you're doing here, we'll start here. So you're fetching the account. You're fetching the ledger object for your account. And then you're making sure that the account still exists, just as a double check. Because otherwise it'll crash and you would rather throw an error instead of crashing. Then you want to make sure that your account has enough account reserve for this new escrow object that you're creating. So you can pull the reserve for the current number of objects that it owns plus 1 and compare that to which would be the necessary reserve that it needs. Whatever the reserve is plus 1, and you make sure that the balance is less. If the balance is less than the reserve, then it doesn't have enough to create this new object, so you throw the tech insufficient reserve error. Then you get the destination account from your transaction. You get the ledger object, the account root for your destination. You make sure that your destination does exist, otherwise you throw another error. And then now we can actually get to the NFT. Actually, just stop me at any point if you have questions, by the way. So then you get the NFT ID from your transaction. You get the token and the actual token info and the NFT page that it's on. So you can remove it from this function. And if that doesn't exist, you throw another error. Then you can remove the token using this helper function that basically just removes the token from an NF token page. This is typically used when you're, for example, accepting an NFT offer. You need to remove it from one account's page and add it to another account's page. If that doesn't work, then you throw an error. This remove token will return some sort of failure error if it fails. Now we can actually create our NFT escrow object. This bit of code was in there before. You create the keylet, and then you create the ledger object. And like I said, I couldn't figure out how to put in an NFT as an object itself, so I put it in an array instead. So we create an empty array, and then we add our token to this array. And then we fill in all the fields of our little ledger object. We put the account in there, the NF tokens in there, the destination, the finish after, and then we commit our changes to the view. Everyone following me? So, yes, question? Yes.
I've got a couple of uses in mind for this.
Yeah.
Would one of them be, because at the moment we run a marketplace.
If you don't mind, questions that are specific to your use case, we can talk about afterwards. Is that okay? I've only got 2 minutes left is all. So I appreciate your question. I just I feel like it might be better for when we can talk one-on-one. Any other questions so far? Okay, so now that we've created our little escrow object, every ledger object needs to be owned by an account. So we need to add it to our account. And so the way we do that is we do this dir insert that we talked about previously. We get the directory node page, the ledger object page that it's on, which I guess kind of functions like NF token pages, but less complex. Yeah. And if you can't get one, then your account owns too many objects, and you throw another error. And you add the owner node, which is the page, to your little escrow object. That basically allows you to search it using account objects or something like that. And if your destination account isn't the account that's sending the transaction, then you want to add it to their directory as well. Both of these accounts own this object. Yeah. And then we can adjust the owner count of your account, which basically just makes sure that your account knows how many objects it owns for easier processing. And then we update our account ledger object, and then we can return success after that. Any questions? Yes.
When can we do it with JavaScript?
The mic.
The question was about when we can do it with JavaScript. I have a very basic proof of concept working, but the JavaScript C++ API is much less friendly, so that'll be a lot more. It'll be a few months before that's available, and probably less nice, but we'll see. All right, that's all I got. Yeah, one more. I have like 10 seconds left, so one more
I was
question.
wondering if that was use case specific, but let's say you have a private XRP ledger network.
You can run this on.
How would you apply that to work with the original XRP ledger code?
So you can, as long as you're running the version of code that I have, which is a separate branch, you can create a plugin on anything. But if you're building it, if you're running it on a network, then all of the nodes on the network need to have this plugin. Otherwise, they will have conflicts on whether they think a transaction is valid.
Okay.
This is running on like a standalone node that's like its own network on my laptop, so it doesn't matter. Yes. All right. Thank you.